Hey guys, welcome to PSSA practice test number 2. You should have already done number 1 through 17 and checked your answers. And you don't have to watch this whole video. Just fast forward to the problems that you missed from your answer key. So anyway, I'm going to get started. So in number 1, it's the one problem that you were supposed to do without a calculator. So hopefully this was easy for you after all of this that we've done all year. So it's a dividing fractions problem. So I'm going to keep, change, flip. Going to keep it to 3/4, change it to multiplication, and flip it to 3/2. I'm going to look for some bow tie reducing, and I don't see any. So when I solve, I get 9/8, which is improper. And I notice they actually have the improper fraction 9/8 right there, so that's going to be my answer. I don't have to change it to a mixed number. All right, now for number 2 through 17, we're allowed to use a calculator. So let's get started with problem 2. It says, Greg's social studies grade is based on 2 quizzes, 2 tests, and 1 project. The table below shows Greg's scores on these items as well as each item's weight in determining his final grade. All right, so quiz 1, quiz 2, here's the grades, here's the weights, okay. Test 1, test 2, wait, all right. So to determine his final grade, Greg's teacher multiplies each score by its weight, adds the products together, and then divides the sum by 10. What is Greg's final grade? All right, so here's what they mean. Greg's teacher multiplies each score by its weight. All right, so let's talk about that part first. So if we take each score and multiply it by its weight, so we're going to multiply here. So the first thing, 78 times 1 is 78. 90 times 1 is 90. Now remember, you're allowed to use a calculator for this. So 85 times 2 is 170. 89 times 2 is 178. And 92 times 4 is 368. Now the next thing I have to do says Greg's teacher multiplies each score by its weight. Okay, I did that. Now then he adds the products together. So now I have to add these numbers all up. So I'm going to add those up on my calculator, and I'll get my sum of 884. Okay, the last thing it says, and then divides the sum by 10. So now I'm going to do 884 divided by 10, which is 88.4. And it says, what is Greg's final grade? Well, it's going to be 88.4. All right, that was a tricky one, so let's go on to the next page. Okay, on the next page, number 3, it says, Kaya plotted the locations of her home in the city of Huntington on the number line shown below. So her home is at 0 and Huntington is at 6.75. Now it says Williamsburg is the same distance from Kaya's home as Huntington, but is in the opposite direction. Which statement best describes how to find the location of Williamsburg on the number line? So let me first plot it here. So Williamsburg is the same distance from Kaya's home, but in the opposite direction. So if Huntington is 6.75 that way, Williamsburg will be 6.75 that way. So that's going to be right there at negative 6.75. So let's read through here and see which ones make sense. So A says the opposite of 6.75 is negative 6.75, so Williamsburg is at negative 6.75. I'm thinking that's true, but let me make sure the other ones don't make sense. B says the sum of 6.75 and 6.75 is 13.5, so Williamsburg, no, not B. C says the numbers 6.75 and negative 6.75 are the same, so Williamsburg is at negative 6.75, or is at 6.75. No, Williamsburg's not at positive 6.75, and they're not the same. D says opposites, such as 6.75 and negative 6.75 sum to 0. So Williamsburg is at 0. Well, Williamsburg is not at 0. So A is definitely the answer. If you had that, give yourself a C. Okay, next problem, number 4. James measures the water level from the top of a dock twice a day. The water level in the morning is negative 2 feet. The water level in the afternoon is negative 6.75 feet. Which statement about the relationship between the two measures is true? All right. You know what I'm going to do for this one? I'm going to draw a picture real quick. So let me just kind of get a square, put it over here so we can see. All right, so here is the water level. Here is the dock. Okay, and I'll draw a picture of James standing on the dock, just so I know it's a dock, because my dock doesn't look like a dock. All right, so James measures from the water level from the top of the dock each day. The water level in the morning is at -2 feet. So if you can imagine this as a number line, let me switch to a different color. And the water level would be at 0, because it represents 0. And the water level in the morning is at -2 feet. So -1, -2. And the water level in the afternoon is at -6.5 feet. So if I kept going, -3, -4, -5, let's say right here, -6.5 feet. And it says, which statement about the relationship is true? So let's check them out. A says a water level of -6.5 feet is higher than -2 feet. So as -6.5. Well, that's definitely not higher than that. B, a water level of -2 feet is lower. Well, -2 is not lower. It's higher. C, a water level of -6.5 feet is the same. No. D, a water level of -2 feet is higher than -6.5 feet. Yeah, here's -2, here's -6.5, -2 is higher. So that correct answer is D. All right, and then let's go on to number 5. It says the ratio of the number of boys to the number of girls in the cast of a school play is 1 to 5. Which statement must describe the cast of the play? All right, so let me write that down. So it's 1 to 5, and that's the number of boys to girls. Okay, A says there are exactly 6 students in the cast. No, that's what's tricky about this one, because a lot of people think, oh, 5 plus 1 is 6. But no, just because the ratio is 1 to 5 doesn't mean there's 1 boy and 5 girls. There could be 2 boys and 10 girls. So A is definitely, it could be true, but it's not necessarily true. B, there is 1 boy for every 5 girls in the cast. That sounds about right, but let me check C. There are 4 more girls than boys in the cast. No, not necessarily. D, there is 1 boy out of 5 students in the cast. No. So B is the only one that must be true. There's 1 boy for every 5 girls. Because if the ratio is 1 to 5, that's the same as 2 to 10, or 3 to 15. So there could be 3 boys, 15 girls, 2 boys, 10 girls, 1 boy, 5 girls. We don't know. But we do know that for every 1 boy, there are 5 girls in the cast. So B is true. Okay, next page. Number 6. For a recipe, Harris uses 2 cups of white sugar for each cup of brown sugar. I'm going to write that down. 2 cups white for each cup of brown. Okay, how many cups of brown sugar does Harris use when he uses 1 cup of white sugar? So, I'm going to think of this as a ratio. So this is white, this is brown, and it says if he uses 1 cup of white sugar, how many cups brown? So to solve this, I would divide by 2 to get 1, divide by 2 and get 0.5, which is half. So A is the correct answer. Okay, number 7. Jasmine earns $36 for 4 hours of babysitting. She charges a constant hourly rate. Which table correctly shows the amount Jasmine earns babysitting for different numbers of hours? All right, so it's $36 for 4 hours. And if I reduce that, or change it to a unit rate, divide by 4, that means she gets $9 for every hour. Now the unit rate's going to help me understand this one. So, let's try this one. Number of hours, 2 times 9 is 18, 4 times 9 is 36, 6 times 9 is 54, 8 times 9 is 72. So, I'm thinking it's probably A, but let me check the next one. 2 times 9, is it 34? No, 2 times 9 is 18. Okay, Is 2 times 9 27? No. Is 2 times 9 32? No. So the correct answer is A. On to the next page, number 8. Alon started in 60% of his team's basketball games this season. He started a total of 12 games. How many games did Alon's team play this season? All right, this sounds like percent proportion to me. Remember, percent over 100 equals part over whole. Now, he started a total of 12 games, so that's the part. How many games did he play? That's the whole. We don't know. Now, you can use cross products, or 60 divided by 5 is 12. 100 divided by 5 is 20, which is D. All right, number 9 says an inequality is shown. X plus 2.5 is less than 20. Which is the greatest value of x from the set of these numbers that makes the inequality true? So what I'm going to do is I'm going to solve this inequality. So I'm going to write it down here. X plus 2.5 is less than 20. Now remember, to solve it, it's just like an equation. I'm going to minus 2.5. I'm going to minus 2.5. Cancel. X is less than, and 20 minus 2.5 is 17.5. So to be a solution, x has to be less than 17.5. So that means 19.5 can't be a solution. 17.5 can't be a solution because it's got to be less than it. So these are the two possible solutions. Now, this says which is the greatest value that makes the inequality true? So 12.5 is the greatest value, B. All right. Number 10, there are 150 children playing in a park. The number of boys, X, playing in a park is greater than 50. All right, so let me write that down. X is greater than 50. And that's boys. The number of girls playing in a park is less than 100. So girls, and that's Y. Y is less than 100. So which values of X and Y could be the numbers of boys and girls playing in the park? So X has to be greater than 50. Y has to be less than 100. So let's go through and eliminate any answers where X is not greater than 50. All right, so it can't be A because X is 35 there. Can't be B because X has to be greater than 50. It can be C because 55 is greater than 50. It can be D. All right, so we're down to 2 answers. Now, the girls, Y, have to be less than 100. So in C, Y, 85 is less than 100. And D, Y, 90 is less than 100. All right, so, okay. So at this point, it's C or D, but I just realized I forgot something. Yeah, this was confusing me for a second, but then I realized this. There are 150 children playing in the park. So, only one of these, I bet, add up to 150. So let's try D. 60 plus 90 is 150. And if I add up C, 55 plus 85, that adds up to 140. So it can't be C. That means the correct answer is D. All right, that was tricky. I didn't see that last part. All right, next one. Gary saves $2.50 each day. All right. Which equation describes the relationship between the number of days, D, Gary saves money, and the total amount of money, M, in dollars that he saves? All right. So the total amount, M, is what we need to find. Now, we know he saves $2.50 each day. So it's going to be $2.50 times the number of days, which would be A. All right, next page. Okay, number 12, a trapezoid is shown below. What is the area? All right, I hope you use the formula for area of a trapezoid. Area is half times height times base 1 plus base 2. Area is half times the height. The height is 3 times base 1 plus base 2, 5 plus 9. And then when you solve that, remember, all you have to do is type it into a calculator. You'll get 21. So the area is 21 square meters. All right, 13. The vertices of a parallelogram are plotted on the coordinate plane shown below. All right, so I see them there. Here, 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 and here. What is the area in square units of the parallelogram? So first thing I'm going to do is I'm going to draw my parallelogram so I can kind of see it here. All right, so remember, formula for area of a parallelogram is area is base times height. So we need to figure out the base and the height of this parallelogram. So let me zoom in here. Okay, so the height has to go straight up. So let me switch to red. So the height is going to be 1, 2, 3. So the height is 3 units. Now the base is going to be basically the bottom of it here. So I'm going to trace that in red. So I have 1, 2, 3, 4, 5, 6, 7, 8. So the base is 8. Let me zoom back out. So area is base times height. Area is 8 times 3, which is 24D. All right. Let's go on to the next page. 14. Rosa built a jewelry box. She first cut all the pieces she would need by using the pattern shown below. So we have a net here. All right, based on the pattern, which phrase best describes the shape of the completed jewelry box? Okay, so A says a cube with a box top. This cannot be a cube because look, it's got rectangles in it. If it were a cube, it would have to be all squares. So this is not a cube, which means it can't be B. Now, rectangular prism says, or C says a rectangular prism with a box top. D says a rectangular prism with no box top. So if I think of this as the top and the bottom, left, right, front, and back, it's a rectangular prism with a box top, C. All right, next one. A rectangular prism is pictured below. What is the surface area of the rectangular prism? So remember, surface area of a rectangular prism, we're going to find the front plus the back, top plus the bottom, left plus the right. All right, we're going to do the circle of fear, death, and destruction part 2. Ready? 13 times 5 is 65. So 2 faces are 65. 6 times 5 is 30. So 2 faces are 30. 6 times 13 is 78. So 2 faces are 78. So next we're going to add up all 6 of those faces. And they all add up to 346, which that means the surface area is C, 346 square centimeters. All right, next page, number 16. Franco asked his soccer team how many glasses of milk and how many glasses of water each player drinks per day. The line plots below show his data. So when I look at the first one, amount of milk here, okay, so each X must be a person. So that must mean that, all right, 2 people drink 0 glasses of milk. 4 people drink 1 glass of milk, etc. Okay, down here's water. So no one drinks 0 water. 1 person drinks 1 glass of water. 3. All right. So which statement correctly describes the number of glasses of milk and the number of glasses of water each player drinks per day? All right. So let's check this out. A says the mean would be a better measure of center than the median for the number of glasses of milk the players drink. All right, so let's talk about this. Mean is a good measure of center when there are no big gaps. So when I'm looking in here, there's a little gap here, but I don't know. I think mean is pretty good. All right, so mean would be better than a median. All right, I'm right now I'm thinking A is a possible answer, maybe, because mean you choose mean if the data is not spread apart, and the data is not spread apart. But let me read the other ones. B says there is less variability. Now variability means differences in the number of glasses of milk the players drink than the number of glasses of water they drink. All right, so variability, basically, how far apart are the numbers? So in glasses of milk each player drinks, if I find the range, remember, range is big minus little. 7 minus 0 is 7. Glasses of water, 9 minus 1 is 8. So that would be your variability. So let's see. There is less variability in the number of glasses of milk. All right. I don't know. Maybe. There's less variability in the number of glasses of milk the players drink than the number of glasses of water they drink. I do think there's less variability. There's more variability in the number of glasses of water. I don't know. This one could be tricky because I'm thinking it could be B. All right, C. The median number of glasses of milk the player drink is greater than the mean number of glasses of milk the players drink. All right, so that means I have to find the median and the mean of each one. So remember, median is the middle number. And mean means I have to add up the numbers and divide by however many there are. So what I'm going to do is I'm going to pause this, and I'm going to find the mean of each one and the median of each one, and then I'll restart it. Okay, so I found here the mean. When I added these numbers up, they added up to 56 divided by 22, and I rounded it to 2.5. So that's the mean. And the median, the middle, would be 2, right around here. Now, for the lower one, the mean, when I added them up, for the mean, 107 divided by 22, and I rounded that to 4.7. And the median, the middle number, was between 4 and 5, so it was 4.5. So now let's see if C is a possibility. C says the median number of glasses of milk the players drink is greater than the mean number of glasses of milk the players drink. All right, so the median number of glasses of milk. So here's milk. Here's the median. 2 is greater than the mean number of glasses of milk the players drink. So here's the mean. Is 2 greater than 2.5? No. So it's definitely not C. That one hurt my head to think about. D says the range for the number of glasses of milk and the range for the number of glasses of water the players drink are the same. So the range for the number of glasses of milk and the range for the number of glasses of water. Well, I already figured out the range. They are definitely not the same, so it's not D. So now, let's talk about A versus B. So let me go back and think about them here. Now, A says the mean would be a better measure of center than the median for the number of glasses of milk that the players drink. So this top one is milk. All right, so let me think about this a little further. So maybe this one isn't true because mean, these two aren't too far off, but you know what? The person who drinks 6 glasses of milk and the person who drinks 7 is definitely going to throw the mean up more. So I'm thinking A might not be true after all, the more I think about it. So let me kind of X that out and let me think more about B. There is less variability in the number of glasses of milk the players drink than the number of glasses of water. So variability, let's look at them here. You see how with the milk, they kind of all, it almost looks pretty the same. They're mostly right around here, except for these two over here. When you look at water, they're kind of all over the place. There's here, and then up, and down, and up, and down, and up. And this is kind of a lot of variability. There's a lot of change going on. So there is less variability in the number of glasses of milk that they drink. So the correct answer for this one is B. But that one is a tough question. All right. Open-ended. Number 17. Here's what it says. It says, Sam and Annika ride their bikes to school. Sam rides his bike K kilometers. Annika rides her bike 2 less than 4 times as many kilometers as Sam rides. Already my head hurts. A says, write an expression to represent how many kilometers Annika rides her bike to school. All right, so let me think through this. Sam and Annika ride their bikes to school. Sam rides his bike K kilometers. So let me write that down. Sam is K. Now, Annika rides her bike 2 less than 4 times as many kilometers as Sam. So Annika, I'm going to start with the 4 times. 4 times whatever Sam rides would be 4K. That's this part. 4 times as many. But 2 less than that would be 4K minus 2. So this expression represents how many kilometers Annika rides her bike to school. Now, it doesn't say to explain or anything in part A, so that's all I need, what I just circled. Now, B says Sam rides his bike at most 2 kilometers to school. So, K has to be less than or equal to 2. Okay, so at most, it can't be more than 2. It can be 2, it can be less than. Now, B says, what is the greatest distance in kilometers Annika could ride her bike to school? Show or explain all your work. All right, so this is going to be Sam here, right? So Sam, I wrote an inequality to represent at most 2 kilometers to school. Now, the greatest distance Annika could ride. That means if, let's say Sam rides his bike to school 2 miles, that means we'd have to put 2 into Annika's into her expression. So remember, her expression is 4K minus 2. Now, the most Sam could ride is 2 kilometers. So I'm going to put 4 times 2 minus 2. And that is 8 minus 2, which is 6. So that means the greatest distance Annika could ride her bike to school is 6 kilometers. I'm also going to label that the greatest distance. Now, let's talk about show or explain all your work. What I just did here is I showed that the greatest Sam's could be is 2. And I put that 2 in Annika's. I wrote down her expression. Then I put 2 in. I put 4 times 2 minus 2. And I solved it. 8 minus 2 and got 6. So this is my answer. So because it says show or explain all of your work, if this is all you show, you're going to get the highest points because you showed the expression, you showed your work, your answer is clear. You don't need to explain. Now, if you did explain, I'll write down an explanation in case you did explain, so just so you can see what it might look like. Now, I'll pause it and write it, and then I'll restart it. Okay, so now, in case you explained it, remember, show or explain means you could do either or. I wrote a sample explanation for this. Now remember, I still kept my work. The expression, I put the 2 in for the K and I got 6. But here's what I said. I said the most Annika could ride to school is 6 kilometers. I like to start with my first sentence as my solution. I took her expression from part A, 4 times K minus 2, and I substituted 2 for K since Sam rode at most 2 kilometers. And that's what I showed here. I substituted the 2 in for the K. And I said, I got 6 kilometers as my solution. So I basically just explained in a few sentences what I did here. I took the expression, I substituted 2, I got 6 kilometers. That's it. All right. Now, let's go on to the next page. Okay, so here's what it says. It says, please refer to the previous page for task explanation. Explain why Sam must ride his bike more than half a kilometer to school. So let's think back to what we knew from the last page. Remember, on the last page, K equals what Sam rides, and Annika rides 4 times K minus 2. So this says, why must Sam ride his bike more than half a kilometer to school? So what happens if, let's say, K equals 1/2? What's going to happen if I put 1/2 in Annika's expression? Well, let's find out. 4 times 1/2 minus 2. So 4 times 1/2 is 2. 2 minus 2 is 0. So if Sam rode his bike for a half kilometer to school, that would mean Annika didn't ride her bike to school at all. Now, that can't happen because on the previous page it says Sam and Annika ride their bikes to school. So if Annika rode 0 kilometers, that would mean she didn't ride her bike. So that can't happen. So now I need to explain that. So what I'm going to do is I'll write a sentence, and then I'll pause it while I'm writing a sentence, and I'll restart it, and then I'll talk about it. All right, so I'm going to start by restating the question. Okay, so when I restate my question, I said, here is why Sam must ride more than 1/2 kilometer to school. Now, I'm going to pause it and write my next sentence where I'm going to try to explain how when you put 1/2 in Annika's expression, how it comes out to 0, and that can't be true. So let me pause it here. Okay, so then I wrote my next 2 sentences here. So I said, if Sam rode 1/2 kilometer to school, Annika would ride 0 kilometers to school. And because I have my work showing up here, that helps my explanation, by the way. That is not possible since both Sam and Annika ride their bikes to school. So this explanation answers my question. I have a little work to show it as well. And it shows the people checking the test that I understand that if I substitute 1/2 in Annika's expression, I would get 0, and that would mean she doesn't ride her bike to school. So he has to ride more than 1/2 kilometer to school. So I'm going to wrap it up by restating my question. And here's what I wrote. That's why Sam needs to ride more than 1/2 kilometer to school. All right, restate my question. A couple sentences explaining why. Restate my question. And that would give you a very good explanation. All right, you're done with me. I hope this helped. And as always, thanks for watching.